All right, so in this lesson, we're going to start finding the area between two curves. In today's lesson, they're going to be expressed in terms of x. All right, so I have the graph. The one on here doesn't look great. I think hopefully the one on your paper is a little better. Where we have f of x is the black function here, and g of x is the red function. So f of x is negative x squared plus 10, and g of x is x squared plus 2. All right, so we're going to find the area between these two curves, or just like talk about what we would do to do that. So we're going to use Riemann sums. We're going to draw a left Riemann sum rectangle that could be patterned to fill the area. So I'm just going to just pick this space right here and just draw a rectangle where the left corner is touching. All right. All right, then how can we represent the height of that rectangle? All right. So I know that from the x-axis to that point, that is going to be the f of x function. The height would be the value of the function there. But I don't want that whole height, so I would subtract off this much of it. So that height can be represented by f of x minus g of x. All right. And then if I want to figure out between what x values we would need to fill the rectangle. So if I just kept drawing the rectangles to fill the area, this is the area we would need to fill. So that's going to be between negative 2 and 2. Right, and to translate that to an integral, it should be the integral from negative 2 to 2 of f of x minus g of x dx. Okay, so that's a big important idea for today. If we want to find the area between f of x and g of x on the interval from a to b, as long as f is greater than g in that interval, and that's what we had here. Everywhere in that interval between negative 2 and 2, f was on top of g. That's going to be given by, we're going to say a for area is going to be the integral from a to b of f of x minus g of x dx, where f of x is going to be the upper curve and g of x is going to be the lower curve. All right. Now, for this to work, the region must be bounded. So there's no open hole. So this is an example of a bounded region. And you can find the boundaries by graphing by hand. Graphing using a calculator. Or solving a system of equations. All right. Now, another thing I need you all to remember is that area is always positive. So if you do these area problems and your integral gives you a negative area, it means that you must have got the upper and lower functions mixed up. Or you made a mistake somewhere in your integration. Now, there are some times when the upper and lower functions switch. So let me show you an example of that. Okay, so let's say we have a function that does this, and then we have a function that does that. Right, and this one's f of x, this one's g of x. And first place they cross down at the x-axis is going to be a, second place is going to be b, third is going to be c. And so this would be the areas that we're looking for. But because the upper and lower functions switch up, we would have to do two separate integrals. All right, so this area, we'll start with the first region from A to B. And on that one, it looks like, I should have done them in different colors. Let me do that real quick. Okay, so on that one, it looks like f is the upper, so f of x minus g of x dx. Then plus, we would do a region from B to C, where the green, or the g, is on top, so g of x minus f of x dx. Right, so if it switches up, we'll have to do separate integrals. All right, so on example 1, we're going to find the area of the region enclosed by y equals x and y equals x squared minus 2. We're going to do this by sketching a picture. So let's just start off with y equals x. All right, and then y equals x squared minus 2 is a parabola that's been shifted down 2. So I know the vertex is there, and then I know I have a point here and here. And then I know I can go up 3, right 1 is another point, up 3, left 1 is another point. So there is my parabola. Right, and then here is the area I'm wanting to find. Okay, so we're going to do the integral, and then I do need to know my boundaries. And so the left side boundary is when x is negative 1. The right side boundary is when x is 2. Now, if you can't get that from the diagram, or you just don't know how to draw it or something, you can do a system of equations where you set these two equal to each other. It's not really a system of equations, you just solve the equation. And then we would get everything on one side. And when we factor it, we're going to get two values, 2 and negative 1. So that's the same 2 and negative 1 that are right there. Okay, and now our upper function is the line y equals x. So this is going to be x minus. Our lower function is the function x squared minus 2. Right, so that's what we're going to want to integrate. All right, so I would distribute the negative, and I'm going to go ahead and put things in descending order. Okay, so I'm going to integrate this by adding 1 to the exponent and dividing by my new exponent. Okay, then I'm going to want to plug in 2 and negative 1. So let's just start with 2. So when I cube 2, I get 8. When I square 2, I get 4, and then 4 times 1/2 is 2, and then 2 times 2 is 4. Okay. Then whenever I put in -1, when I cube -1, I get -1, and a negative times a negative is positive. There I would get +1, and then I would do 2 times -2. Okay. And then you can find a common denominator and do all that stuff, or you can just trust me that you get 4.5. I don't want to waste time on the arithmetic today. So that, or 9/2, either one, is the area of that region bounded by those two curves. Okay, let's look at example 2. So let R be the region enclosed by y equals e to the 2x minus x squared and the line y equals 2. And we're going to find the area of R. So that is this region right here. It is bounded. I do need to know what my boundaries are, but because this is not a normal type of function that we can just solve, we're going to use the calculator in this case to find the boundaries. All right, so let's see what we got going on. All right, so I'll just put that first one in for y1 and the second one in for y2. And just take a look at the graph. There we go. And what we want to know is where they intersect. So second trace, number 5. All right, so we get kind of close. And then I get that one intersection point is that decimal. So I'm going to show you a little AP exam trick. What you would do is just say A is equal to that decimal. All right. I'm sorry, let me show you what I wrote. All right, so we put y1, this one, and y2, that one. Okay, and we'll go back and find that other intersection point. Second trace, number 5, and then move close to that one, hit enter 3 times. So then on your paper, you would write that B is equal to that decimal. So now when I write my integral, I don't have to write out that ugly decimal. By telling the AP people that's what A is and that's what B is, I can just go from A to B. And then in this case, the top function or the upper function is e to the 2x minus x squared. And we're going to subtract our bottom or lower function, which is 2, and then dx. And then we'll just let the calculator do this for us. Now don't forget that we have that e function in y1, so we can use it. And then I'm just going to go ahead and type that decimal in and store it. So the store button is right beside the 1. I'm going to store that for A. And then the other one I'll store for B. Okay, so now when I type my integral, I can just go from A to B. Right, and then for the E function, I'm going to go to alpha trace to y1 because that's where I typed it. Subtract 2 from that, and then a dx. Okay, that's what the value of that integral is. That is that area. we just want to make sure we either round to 3 decimal places or truncate to 3 decimal places. Okay. And then example 3 is one of those situations where the upper and lower functions are going to switch. So that's what we were doing here, where you have to do separate integrals and add them together, right? So I have 2 curves. One curve is a cubic function, and it's kind of hard to see. I'm going to trace over it with green. This one is the cubic. Right, and then I'll leave the other one blue. That is the quadratic function. Right, now this one, it works out nice and beautiful that I can tell that my boundaries occur when x is 0, when x is 2, and then when x is 4. All right. So for my area, it's going to be, we'll just start with the first region that the integral needs to go from 0 to 2. On this region, the quadratic function is on top, so that function is 4x minus x squared. Okay, and from that, I'm going to subtract the lower one, which is the cubic function. Okay, and then dx. Right, and to that, I'm going to add the other integral. This one is going to go from 2 to 4. This time, the cubic is the upper, and then the lower is the quadratic one. I technically should have those in braces too. Ooh, okay, so we have some algebra to do before we start trying to integrate. So I'm going to distribute that negative, and then I'm going to combine like terms. Same thing here, distribute that negative, and then combine like terms. All right, and then I'm just going to go ahead and integrate. So add for my new exponent and then divide by whatever that is. Okay, and then I just have a whole lot of plugging in to do. So we'll start with plugging 2 in. And when I raise, when I raise 2 to the 4th, 16 divided by 8 is 2. 2 to the 3rd is 8. 2 squared is 4 times 2 is 8. All right, then I need to subtract what I get when I plug in 0, which is just going to be 0. Okay, and then over here, I'm going to need to plug in 4. And then I'm going to plug in 2. Okay, so 2 minus 8 plus 8 minus 0 is 2. And then 64, and then minus 232 is 0. And then again, those 8 subtract away, so it's minus -2 or +2. So that area is 4. All right. So what I want y'all to do for your assignment on page 442, do number 2, 3, 6, 8, 17 through 20, number 24, and then these two I want you to use the calculator to do. 30 and 50. Sorry, 34 and 50.